Hello, fourth graders. This is lesson 10.6, Find and Draw Lines of Symmetry. Please pause to write the lesson number and title in your notebook. Today's lesson objective is I can identify and draw lines of symmetry. Please pause again to write the I can statement in your notebook. Okay, let's begin with unlock the problem. How many lines of symmetry does each polygon have? So activity 1 wants us to find lines of symmetry. They've drawn a triangle on a piece of paper that all sides have equal length. Step 2 says fold the triangle in different ways to test for line symmetry. Draw along the fold lines that are lines of symmetry. So I don't have a piece of paper that I can fold and show you, so we're just going to go ahead and draw them on step 1's picture. So let's first draw a fold line to test to see for a line of symmetry that is vertical through the triangle. Okay, let's think. Do the two parts on each side of the line match exactly? Yes, they do. So a triangle has one vertical line of symmetry. Let's try a diagonal line of symmetry. I'm going to start in the bottom left corner and draw through the right side of the triangle. Okay, you can see my next fold line. Now think again. Do the two sides match equally? Yes, they do. So far our triangle has a vertical line of symmetry and one diagonal line of symmetry. Okay, let's try diagonal the other direction. So I'm going to start in the bottom right and draw up through the left side. Okay, do the two sides match exactly? Yes, they do. So a triangle in our chart below has 3 sides and 3 lines of symmetry. Now, I want you to think and answer the question in the purple box that states, is there a line of symmetry if you fold the paper horizontally? Please pause to answer that question now. Okay, step 3 asks us to repeat the steps for each polygon shown and to complete the table. So if you want to take a piece of scrap paper and draw out these shapes and fold them to find the lines of symmetry, you definitely can, but I think there's a faster way that I want to show you. So if we look at square, we know that we have how many sides in a square? We have 1, 2, 3, 4 sides. Okay, now with the triangle, we had 3 sides and we had 3 lines of symmetry. Do we think that a square might have 4 lines of symmetry? Let's find out. Could we draw a line of symmetry straight down the middle and have the two sides match exactly? Yes. So that's one line of symmetry for a square. Okay, now let's try horizontally through the middle. Yep, both sides would match exactly on that one too. So that's 2 lines of symmetry for a square. What if I were to take it and go diagonally from corner to corner? Would 2 sides match exactly? Yes, they would. What if I did it the opposite way? The 2 sides would definitely match exactly. So a square with 4 sides has 4 lines of symmetry. 1 vertically, 1 horizontally, and 2 diagonally. Alright, a parallelogram. How many sides do we have? 1, 2, 3, 4 sides again. Okay, do we think that there could be 4 lines of symmetry again? Let's see if our prediction is correct. Okay, to make things visually easier, I'm going to recreate this parallelogram down below. Okay, I'm going to start with a vertical line of symmetry. So if I go straight through it, do we have 2 equal sides on either side of the line of symmetry? No, because this vertex up here is not reflected across the line on this side. So unfortunately, that is not a line of symmetry for this parallelogram. Okay, now let's think about a horizontal line of symmetry. Okay, but again, this vertex is not reflected across the line down here. Same with this one is not reflected across up here. All right, so we don't have a horizontal line of symmetry for this parallelogram. Okay, what about a diagonal line of symmetry? I'm going to start the diagonal line of symmetry in the lower left-hand corner and go to the upper right. Okay, the two sides do appear to be equal. This vertex was reflected across the line, so we can say that has one diagonal line of symmetry. What if we did the diagonal the other direction and we went from the shorter corner across? Again, these two vertexes were reflected and the sides do appear to be the same. So a parallelogram has 4 sides but only 2 lines of symmetry. Now let's think about a rhombus. How many sides does a rhombus have? 1, 2, 3, 4. So it has 4 sides again, and the shape is very similar to our parallelogram that we drew down here. So if we think, could we draw a vertical line through the rhombus and have both sides match equally? No, probably not, because the vertexes would not reflect across the line perfectly, just as it did in the parallelogram. Could we draw it horizontally and have both sides match exactly? No, those wouldn't match exactly either. But if we went from the top of the rhombus in this short corner across, those two parts would match exactly. Or if we went from the long corners across diagonally, those sides would match as well. So a rhombus is like a parallelogram, and it has 4 sides and only 2 lines of symmetry. Now a trapezoid again has 1, 2, 3, 4 sides. However, if we were to draw our lines of symmetry diagonally, again you would see that the sides do not match exactly. If we draw it the opposite way diagonally, we run into the same problem. So let's try a horizontal line of symmetry. Okay, we see that the bottom is definitely bigger than the top. So those do not match exactly, and the vertex all the way out here is not reflected on the other side. So let's go to our very last option of if we draw one vertically through the middle of the trapezoid. Those sides match exactly. So a trapezoid has 4 sides like a parallelogram, a rhombus, and a square, but only has 1 line of symmetry. Our final shape is a hexagon, which has 1, 2, 3, 4, 5, 6 sides. So on this 6-sided figure, let's think through in our head, could we start at each one of the vertexes with a line of symmetry and have it be equal? Well, let's test a few to be sure. So if I were to draw diagonally through these 2 points, would the 2 sides match? Yes, they would. Let's try horizontally through the middle. Yep, they match. Okay, let's try last one vertically. Those match as well. So we can say that even though a hexagon has 6 sides, it still has 6 lines of symmetry that start at each one of its vertices. Please pause to make sure your page looks like mine before continuing. All right, 4th graders, you're almost finished. Just return to your teacher's webpage and complete the exit slip. See you tomorrow.